Okay, guys, looking at the worksheet I gave you while I was gone, just quickly going over the answers. For the first one, where you're determining the acceleration value for the objects, basically all you have to really do is start off with our net force. If we look at our net force equation, we know that the net force in the x direction is equal to mass times acceleration in the x, which equals 12 newtons. The only problem is we don't know what our mass is. So for that, we end up looking at step 2 here, which is our force of gravity. We know that the force of gravity is 19.6, and we know force of gravity is mass times gravity, and we know little g is 9.81. So we solve for mass by dividing 19.6 by 9.81, and we determine that the mass is equal to 2 kilograms. Now that we have the mass, we can plug it into our equation here. So net force is equal to the mass times the acceleration, that should be an x, which equals 12 newtons. So we divide both sides by 2, and we get the acceleration is 6 meters per second squared. So that's number 1. For number 2, or the same one, it's really similar. We start off with the same way. We look at the net force in the y. We know the net force in the y is going to equal 0 because we see that the normal force and the force of gravity are the same, so they're going to cancel each other out. So our acceleration in the y is going to be 0. We could have done this just by looking at it. We don't have to actually do this whole equation. We can just kind of like just say acceleration in the y is 0 because they cancel each other out. If we look at the force in the x direction, the net force in the x direction is going to be equal to the two forces, which right now are just the force being applied. Change that to a blue. Which is the force being applied and the force of friction. So the net force is simply equal to the force applied, which is 12 newtons minus 8 newtons. And this is equal to the mass times acceleration in the x. So the mass times acceleration in the x is equal to 4 newtons. Now we're trying to find the acceleration here, but in order to do that, we first need to find out what the mass is. So we jump over here to step 3. We calculated the mass by knowing that force of gravity equals mass times gravity. We know the mass of gravity, which is the same as the number before. And we look at it as m times 9.81. So we just divide by 9.81. We get 2 kilograms. We plug in our 2 kilograms back into this mass of AX. So 2 kilograms times AX equals 4 newtons. We divide both sides by 2, and we find out that the acceleration is 2 meters per second squared. So we found that acceleration. For number 2, the question just seems to ask you to find the components of the force. So to find the Fy component, we just simply use our trig. We know that sine of 23 degrees is equal to the opposite, which is our Fy, divided by our hypotenuse, which means the opposite is 13 sine of 25. And we plug that into our calculator and we get 5.08 newtons. For the x component, we look at the trig function. 13 cosine of 23 gives us our x component. So that means that comes from cosine of 23 is equal to the adjacent over the hypotenuse. So 13 cosine of 23 gives us our fx, which equals, when we plug into our calculator, about 11.97 newtons. That's it. For the next one, we do the same thing. 52 sine of 40, the hypotenuse times sine of 40 gives us our opposite, which is 13.43. And 52 cosine of 40 gives us our adjacent, which is 39.83 newtons. So now for 3, we have a bit of more information. We're supposed to use our information to help us find the acceleration. So it's a combination of 1 and 2. The first thing we want to do is break up this force into its components. So we know the angle, we know the hypotenuse because it's given to us here, right? We know the angle and the hypotenuse, so we can find its x and y components by simply using 13 sine of 23, which is the hypotenuse, gives us our y component, and 13 cosine of 23 gives us our x component, so we have our x and our y. from then on, we move to our next step, which is finding the normal force. The normal force is the force exerted by the ground. So we figure out what force is left. We have 11.97 newtons pointing down and 5.08 newtons pointing up. So that means the normal force has to equal 6.89. We just subtracted them, because pretty much the normal force plus the Fy, because it's pointing up, minus the force of gravity should equal 0 to cancel out, because so the normal force has to equal the force of gravity. It becomes positive because we move it over, plus minus Fy, which is pretty much what we have here. Force of gravity minus Fy equals the normal force. So the normal force makes up 6.89. So now that we know our normal force, we plug it in, and then the next one is step 4, finding the net force. The net force is easy because we just simply look at if we look at our problem. It stops magnifying here. If we look at our problem here, our y's cancel out and we only have one force acting in the x direction. The only force acting in the x direction is 11.97 newtons. So our net force has to equal that 11.97 newtons, because it's the only force that doesn't cancel out. It's the only force acting in the x. So then for the next step, before we look at our acceleration, I want to calculate the mass, because I know that's going to come in handy later. So I find out my mass by knowing that force of gravity equals mass times gravity. We know that the force of gravity is 19.6. We know little g is always 9.81. So solving for it, we can get the mass. So when we look up here, we know that the net force in the x is equal to the mass times acceleration dx equals the net force. The net force is 11.9. We know the mass is 2 kilograms. So we can figure out that the acceleration is 5.96 meters per second squared. And we're done with that. For the next part, I'm working on this whole zooming in thing. For the next part, it's the same problem as number 3, except the only difference is we're adding a frictional force. So all we have to do is pretty much all the values, these values in red all stay the same. These are all the same values from the last problem. Our normal force doesn't change, our Fy, our Fx, even our force of gravity doesn't change, which means our mass is still 2 kilograms. The only thing that does change is the fact that we now have a force of friction. So if we look at our net force in the x, our net force of the x is now made up of 2 forces. Our net force of the x, which equals the mass times acceleration of the x, is equal to all the x components added together. So we have 11.97 positive, force of friction in the negative. We know that the force of friction is 8 newtons. So 11.97 minus 8 newtons is 3.7 newtons. This is our net force. Our net force is 3.7 newtons. So to find our acceleration of the x, we know that the mass times acceleration of the x, right? Mass times acceleration of the x equals 3.97 newtons. We know the mass is 2 kilograms, so we divide both sides by 2, and we get 1.99 meters per second squared. This is just another way of writing meters per second squared.